Good morning. I've prepared this video to review the Torque Tester Galil program. So what I'm showing you on the screen now is an explanation that I typed up, basically kind of translated from the Galil DMC program in plain English as best as I could. So if you read through this, it explains each routine in the Galil program. Right now, what I'm showing you are some highlights in green that I want to go over. So first of all, when you do see the Galil routine that I've commented, it's called DMC extra commented bracket text file.dmc. That is a text file. You can open it up in any text editor. You can also open it up with the Galil programming software. It'll recognize the .dmc extension on it. But please don't use this as a production version. Inadvertently, I can enter some errors in there, and if you try to run it, it may or may not crash on that line that I put an incorrect command in there. Anyways, just use it for learning the program and debugging. So in this Word file here, you'll see I reference the routine name in the Galil. So every routine name is preceded by a pound symbol or hashtag symbol, and you can look at that in the Galil program, and if it's important, I've highlighted it in here. In the Galil program, there's 3 axes. X is the rotary, Y and Z are vertical. And I haven't seen the machine run. I've seen a few videos, but Y and Z are hydraulic, and they move the test platform up and down against the leg which is being extended. X-axis is rotary, so a servo motor comes in, clamps onto the landing gear, rotates that, and the leg of the landing gear extends down. So the pound routine is the first routine that runs. It runs automatically. If you reset the Galil cycle power, this routine is going to run. So basically, inside there, they configure the Galil parameters. They turn off the axis. They set some gains in there. They set up a bunch of DMC variables. DMC is a digital motion controller. That's what Galil calls their controller. And they set up some arrays in there for communication to the PLC through Modbus. Next, down through auto, they have an auto 1 label, and they set some more variables in there. They have some flags that they use. For example, internally, so homed equals 0 when it's not homed. Homed equals 1 when it's homed. Calib or calibration when it's not calibrated, and calib will equal 1 when it's calibrated. They communicate to the PLC, which I think is a slick. They have the various flags in there that get set or reset. They communicates to the PLC, which I believe is Slick 500, through Modbus. And you'll see throughout the program there's an STS variable they use internally. I'm not sure what that exactly means, the STS, but they basically just set values in and they write it to the through Modbus. So for example here, inform the PLC through Modbus register 40 that the DMC has initialized. So they set it to 2. So in the PLC, somewhere in there, they'll be looking for that register to be written to number 40, and when it's 2, then that means something to the PLC. And you'll see that all throughout the program. It's writing to Modbus. For example, it's writing 3 here and 6 here, and that means, like I said, that means something. Once the auto routine is done, they jump into this pound main routine, and pound main runs continuously. It's like a PLC program. It just keeps looping from the beginning of it all the way to the end, and there's a jump label in the program, and it just basically, I have repeat pound main here. It's just basically in the program says JP jump pound main. So inside the main routine, they do configure the inputs to trigger what they call the input interrupt routine. So that is a routine that gets executed automatically no matter what's going on. Whatever's currently happening just kind of gets left, and it jumps into this pound INT routine. So if you look through the code, you can read through this description, but basically what it does is the servo drive ready, input number 2, input number 4 is reset, and input number 8 is PLC ready. When these are either on or off, it'll jump to the pound INT routine. Just a quick note before I continue too much further. At the end of this document, it describes the inputs and outputs. So there's an input. When the input on the Galil is on, it'll start the test. That's number 1. Number 2 is servo drive ready. Number 3 is spindle ready. Number 4 is reset. 5 is pre-stage position. I couldn't find that on your schematic, but I found it in the program. And home, that's not on the schematic either. There's a spare. Number 7, 8 is PLC ready. So these are either on or off depending on what the PLC is looking for. So if the PLC wants to perform a homing routine, it'll turn on the home output. There's some outputs from the Galil to the PLC as well. Torque test done. I didn't see this wired, so I'm not sure if it's still used, because a lot of these results from the test go through Modbus. There's an output for test fail average and test fail max. These might be opposite logic in the PLC, so normally closed versus normally open. There's an output when it's homed, when it's calibrated. Number 5, pressure plate raise, when the Galil needs a pressure plate raised, and when it needs the pressure plate lowered. And a DMC ready, saying that this program is running. So let me just go back up to where we left off. I think we were on the INT. No, we weren't. We were back up on the main routine. So as I said, the main routine, it's just going to keep looping through this routine, up and down continuously. Never ends. It's like a scan of a PLC program. You can see in there before it starts the test, it turns output 8 off, which is the DMC ready. It's telling the PLC it's ready to go, and it waits 100 milliseconds, probably just to make sure it gets that signal. It homes the y-axis, which is the vertical axis. There is an encoder on the y-axis, I believe. There's a couple routines for reading the PLC inputs through Modbus and writing out the status flags to Modbus. There's also a routine here to read real number data from the panel view, HMI. Well, it's going to go through the PLC. And it calls a calibration routine. The calibration routine basically just starts extending the leg of the landing gear, and as it's moving it at high speed, it checks the actual torque that's being registered to run at a high speed. It performs a homing rotation on the Y, and it goes down and calls the test routine. So the test routine is performing a torque test on the gear. Afterwards, it saves the values for the PLC to read through Modbus, and it indicates a little bit later on that DMC is still ready. I'm not sure why it does that twice, and it repeats this. So pound INT routine, I discussed it briefly above. You can read through here what it does. stops the X and Y axis, Y commanded to 0 volts. Just a quick note about the Y and Z axis. When there's 0 volts, I believe it's going to command 0 pressure on those hydraulic cylinders. Calibration routine calculates the average friction torque while rotating the x-axis at high speed. Once it's finished doing that, it writes the average friction DMC RIC to the PLC through Modbus register 16. It sets a flag internally that it's completed the calibration, and it turns off a calibration request flag to the PLC because I believe the PLC will set that through Modbus. And it writes a calibration request flag to the PLC through Modbus register 23. So it tells it it's finished. It goes to 0, so it's done. The PLC will recognize that. And once it's done, it returns control back to the calling routine, which is, I believe, pound main. So this is pound calibration. If you go back to the main routine, you'll see, here it is here, call calibration routine. Next of interest was the test routine. And this is the test that's actually, what it does is it applies a opposing load against the landing gear while the x-axis is extending the landing gear. During this process, the commanded voltage to the servo drive is monitored and mathematically converted to torque. The analog torque command voltage is sent to the x-axis servo drive from the Galil DMC. So what's happening is it's going to extend the leg of the landing gear, and as it's doing that internally, because it's going to set a velocity to travel at, and as that's happening, it's going to be sending out a commanded voltage to command torque from that motor, and it monitors it internally. There's a way for the Galil program to grab that value, and it converts that to torque by using this 3.05 foot-pounds per commanded volt. And if you look at the end of this document, I explain how they arrive at that. It's not an exact value. You know, if I had to throw it off the top of my head how accurate it is, I'll say, you know, plus or minus 10 to 20%. And that can change once the motor and drive get older. Inside this routine, there's a pound AVG or average routine that calculates the average torque, and it looks to see if the motor has stalled or if it's failed the average, and it takes action according to that. The record routine is probably something you guys would want to look through. So what it's going to initially do is it's going to take 4 samples right away of torque. And that's voltage, and it's convert that to foot-pounds by multiplying by 3.05. It's going to subtract off the average frictional torque from the calibration routine, and then it's going to calculate the average sample torque for each sample. At the end of that, it's going to call the calc routine and update torque calculations and return to the calling routine. So the important thing to get from here is it's going to take, for one sample, it's going to take four samples and then basically kind of average that out. Once it takes those 4 and grabs the average of it, it jumps to this calculation routine, which keeps running sum of all the average sample torques from above. It saves a live value for the PLC and writes it through to Modbus. Waits 20 milliseconds and then it's going to report the highest and lowest torque through PLC through Modbus. It does a check in here if the torque exceeds the stall torque, and if it doesn't exceed the stall torque, it'll just keep going. There's also an average routine. You can read through that. I went through the Galil inputs and outputs already, and there's a detailed note on the end of this regarding how it calculates or converts from commanded voltage to the Galil to foot-pounds. There's a couple other videos I'm going to have on here with going a little bit detail of the Galil program and to the Galil software, how to communicate, how to send a few commands that might be of interest to you. So just to point out these files, so the one I just showed you is the Torque Tester Program Explanation.pdf, and the other one that I've put on that's available to you guys is the actual Galil program that I commented. As I said, it does have a .dmc extension, but you can open that with any text editor. Thank you.